This is SpaceTime Series 26, Episode 18. Coming up on SpaceTime, the James Webb Space Telescope suffers a glitch, NASA and the Pentagon to build nuclear-powered rockets for Mars, and the world's largest aircraft takes to the skies. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
One of the key instruments aboard NASA's $10 billion James Webb Space Telescope has suddenly gone offline. The issue focuses on the near-infrared imager and slitless spectrograph, which is used to detect first light, that is, the era of recombination of the universe, and to study the chemical composition of the atmosphere of exoplanets. Mission managers say the instrument went silent due to an internal communications error, which has led to the software timing out. There's no indication that the instrument's damaged in any way, and the rest of the spacecraft appears to be operating nominally. The near-infrared imager and slitless spectrograph complements the other instruments on Webb by providing unique observational capabilities between 0.6 and 5 nanometers. It has multiple filters, allowing it to resolve light from objects that are very close together. The instrument was built by the Canadian Space Agency, which also built the Fine Guidance Sensor, which is physically combined with the near-infrared imager and slitless spectrograph, but is a separate instrument. Unlike its predecessor Hubble, which could be repaired during a service mission by one of the space shuttles, Webb's location 1.6 million kilometers away from the Earth places it far beyond the reach of any manned spacecraft. And that makes this issue bad news for the teams of astronomers who have lined up to use the technology. But it's not the first time that Webb's had problems. Back in December, Webb went into safe mode suddenly for about 3 weeks. That turned out to be due to a software issue in its attitude control system, which normally helps keep the observatory positioned and pointing correctly. That issue is now under control following changes to the commanding system. Meanwhile, the telescope's mid-infrared instrument was also briefly non-operational in August. That was because of growing friction involving some of its moving parts. Scientists have now resumed operations with the instrument, but are carefully monitoring its movements. This is SpaceTime. Still to come, NASA and the Pentagon are planning to build a nuclear-powered spacecraft to travel to Mars, and the world's largest aircraft takes to the skies. All that and more still to come on SpaceTime. NASA and the Pentagon are joining forces to develop a nuclear-powered rocket engine in preparations for sending humans to Mars. NASA Administrator Bill Nelson says the agency will team up with DARPA, that's the Defense Advanced Research Projects Agency, to develop and demonstrate advanced nuclear thermal propulsion technology as soon as 2027. The technology would allow astronauts to undertake more distant deep space journeys in less time. Fast transit times reduces the risk astronauts face. That's because longer trips require more supplies and more robust systems. And it also means greater exposure to deep space radiation. Other benefits to nuclear-powered spacecraft include increased science payload capacity and higher power for instruments and communications. NASA says nuclear thermal rockets can be more than 3 times as efficient as conventional chemical propulsion systems, thereby reducing transit times. The nuclear thermal engine would include a fission reactor to generate extremely high temperatures. That would heat some sort of liquid propellant into a gas, which would then expand through a nozzle to provide thrust. Known as the Demonstration Rocket for Agile Cislunar Operations, or DRACO, the agreement would see NASA's Space Technology Mission Directorate lead the technical development of the nuclear thermal engine, which would then be integrated into an experimental spacecraft developed by DARPA. Of course, this isn't the first nuclear rocket project between NASA and the US military, but it's been an awful long time between drinks. NASA conducted its last nuclear thermal rocket engine test more than 50 years ago, but that program was eventually abandoned due to budget constraints brought about by the growing costs associated with the early development of the Space Shuttle program and the Nuclear Non-Proliferation Treaty. As well as the thermal rocket design, NASA are also looking at another project which would see small nuclear bombs exploded behind a rocket, providing impulse from nuclear shockwaves to maintain forward speed. That idea was also eventually abandoned. Meanwhile, Rolls-Royce have also unveiled an early-stage design for their own new space nuclear reactor. The fission reactor could be used to shorten travel times to the Red Planet or powered manned bases on the Moon or Mars. The company released its early-stage design of a micronuclear reactor in response to a 2021 agreement with the United Kingdom Space Agency to study future nuclear power options for space exploration. Rolls-Royce say that each nuclear pellet will be encapsulated in multiple protective layers acting as a containment system, allowing it to withstand extreme conditions. A different type of nuclear power is currently used in many existing spacecraft. They're known as radioisotope thermoelectric generators, or RTGs, and they've long been used to provide electricity on robotic missions going all the way back to the Pioneer and Voyager spacecraft. Today we see them used to power NASA's Mars Curiosity and Perseverance rovers. They were used on the Cassini mission, and they're also powering New Horizons. But RTGs are really more like nuclear batteries, generating electricity from the heat being given off by the radioactive decay of plutonium. This is SpaceTime. Still to come, the world's largest aircraft takes to the skies, and in February's Skywatch, the spectacular constellation of Orion and the nearby massive ticking time bomb of Betelgeuse are among the highlights of the February night skies on Skywatch. The world's largest aircraft, Stratolaunch's Rock, has successfully completed its second captive carry test flight. The mission carried the hypersonic Talon separation test vehicle on its center spar, mounted between the massive six-engine jet's twin fuselages. The test flight above California's Mojave Desert lasted more than 6 hours. It was the 9th test flight for Rock and helps lay the groundwork for the first drop tests, which are expected later this year. The huge aircraft with a wingspan of 117 metres was originally developed to drop-launch medium-sized rockets into space from mid-air. It would have been similar to Virgin Orbit, which drop-launches its Launcher 1 rockets from a converted Boeing 747 airliner named Cosmic Girl, and Northrop Grumman, which drop-launches its Pegasus rockets from a converted Lockheed L-1011 TriStar airliner named Stargazer. However, a change in ownership has seen Stratolaunch change focus from air-launched rockets into space to hypersonic research and development instead. The flight comes as the last Boeing 747 completes construction of the company's Seattle plant and undertakes its delivery flight to Cincinnati. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian and Gregorian calendars. It's also the shortest month of the year and the only one which is a length less than 30 days. The month is 28 days in common years and 29 in leap years, with a quadrennial 29th day being called a leap day. This additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. Because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year tend to drift over time with respect to the event the year is supposed to track. By inserting an additional day every fourth year, this drift can be corrected. The extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Similarly, in the lunisolar Hebrew calendar Adar Aleph, a 13th month is added 7 times every 19 years to the 12 lunar months in its common years, in order to keep its calendar from also drifting through the seasons. And in the Baha'i calendar, a leap day is added whenever it's needed in order to ensure that the following year begins on the vernal equinox. The length of a day is also occasionally changed by the insertion of leap seconds into Coordinated Universal Time, or UTC, more often referred to as GMT or Greenwich Mean Time. This is needed because of the variability in Earth's rotational period. But unlike leap days, leap seconds aren't introduced on a regular schedule, since the variability in the length of the day is not entirely predictable. Okay, let's turn our attention to the sky now. And throughout most of February, sky watchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as two separate streams, although they rarely produce more than 1 or 2 meteors per hour. They usually peak around February the 8th, and to see them at their best, you really should be looking towards the east a few hours before dawn. Okay, looking north now, and high in the sky is the famous constellation of Orion the Hunter. Orion is one of the best known and most recognized constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon, who was also known as Neptune, the god of the sea in Roman mythology. Orion was a mighty but egotistical and conceited hunter, who once boasted that his skill would allow him to kill all the world's animals. So the earth goddess Gaia sent Scorpius the scorpion to kill him and save the animals. Orion was stung in the shoulder, but then the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Now, a variation of this fable speaks of Orion getting a little bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship and tricked Artemis into testing her skill by shooting an arrow at a distant speck on the ocean. What Artemis didn't know was that that speck was actually Orion, swimming to escape the giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body in the sky as the stars we see today. Similar variations to this story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. The very earliest depiction that's been linked to the constellation Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated that it would have been fashioned somewhere between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identified by its rectangle of 4 stars, surrounding a central trio of stars in a row which form Orion's belt. And hanging from the belt are the stars which make up the Sword of Orion. To those of our listeners in the southern hemisphere, Orion appears to be upside down, with the sword on his belt pointing upwards. And if you look really carefully, you'll notice that the middle star in the sword looks a bit fuzzy. That's because it's not a star, but rather a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, M42 is the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is more than 24 light-years across, and it contains as much mass as 2,000 suns. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. The Orion Nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of nearby massive stars in the nebula. The Orion Nebula contains a very young open cluster known as trapezium due to the asterism of its 4 primary stars. The trapezium itself is a component of the much larger Orion Nebula cluster, an association of around 2,800 stars within a diameter of just 20 light-years. The brightest star in the constellation of Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion's sting on Orion's shoulder. Currently known as Betelgeuse, and commonly referred to by the public as Betelgeuse, don't say it 3 times, the names are both tortured mispronunciations of the original Arabic name Ibtal-Yawza, meaning the hand of the big man being Orion the Hunter. Located some 643 light-years away, Betelgeuse is the 9th brightest star in the night sky. And it's big, really big. In fact, red giants like Betelgeuse are among the largest stars in the universe, at least in terms of volume, although they're by no means the most massive or luminous. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of the Sun, and it shines with some 100,000 times the Sun's brightness. If it were placed at the location of our Sun at the center of our solar system, its visible surface would extend almost as far out as Jupiter, engulfing the orbits of the planets Mercury, Venus, Earth and Mars, as well as the main asteroid belt. Betelgeuse began its life around 10 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are spectral type M red stars, often referred to as red dwarfs. Each spectral classification system is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then Roman numerals added to represent luminosity. Put them all together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Red supergiants are fascinating objects. After spending billions of years fusing hydrogen into helium in their core, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing outwards and gravity pushing inwards stops, with gravity winning. The entire mass of the star then comes crashing down onto the core. This causes a dramatic increase in the core's pressure and consequently temperature. Things get hot enough to trigger what's called a helium flash. This causes the core helium, which has been created in the star, to begin fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has now moved down into that region where the temperatures and pressures are high enough for hydrogen fusion into helium to commence in a shell around the core. Now, as all this is going on, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. And as the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder. Hence the star has become a red giant. Small stars like the Sun eventually lose their outer envelopes completely, which continue expanding outwards as planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which is then left to slowly cool down over the eons of time. However, stars with masses more than around 8 times that of the Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium in the core fusing into carbon and oxygen. They have enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while the shell burning around the core also fuses progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. Eventually they'll explode as core collapse supernovae, ending up as either super-dense strange objects called neutron stars, or even stranger objects called black holes. singularities of infinite density and zero volume, where the laws of physics as science understands them no longer apply. It's too early to tell whether Betelgeuse's ultimate fate will be as a neutron star or black hole. As a red supergiant, Betelgeuse is reaching the end of its life, and it's expected to explode as a core collapse or Type II supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean a million years from now. When it does explode, Betelgeuse will temporarily outshine all the other stars in our galaxy, and it will be clearly visible in the daytime sky on Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho star. That was in 1572, and that was before the invention of the telescope. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel, the second brightest star in the constellation Orion. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, is located some 863 light-years away and has about 23 times the mass of the Sun. The star's already exhausted its core hydrogen supply, and it's swollen out to between 79 and 115 times the Sun's radius, and is somewhere between 120,000 and 279,000 times as luminous. Like Betelgeuse, it's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. Rigel A pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods ranging from several days to a few weeks. Rigel A's companion star, Rigel B, is some 500 times fainter than the supergiant, and it's only visible with a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main sequence blue-white stars. Main sequence stars are those happily fusing hydrogen into helium in their core. And spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, at least from our viewpoint on Earth, by their spectroscopic signatures. The 2 stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. And one of those stars, Rigel BB, itself may be a binary. It appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 25 million years. Now that's old enough for a star of this mass to have consumed much of the hydrogen in its core and begin the process of evolving away off the main sequence into a blue giant. One of the most stunning nebula in Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1,500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulae simply because of the shape of its swirling clouds of dark dust and gas, which really does bear an incredible resemblance to a horse's head. To the west of Orion's belt, you'll see a V-shaped grouping of stars which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V is also part of a large open star cluster known as the Hyades. One of Taurus's eyes is the giant orange star called Aldebaran, or the Follower, which is located around 65 light-years away and has about 1.5 times the mass of the Sun. Aldebaran is thought to contain a number of Jupiter-sized planets. Aldebaran's already evolved off the main sequence, having exhausted its core hydrogen fuel supply. It follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 443 light-years away. There's a story in Greek mythology which tells us that Orion fell in love with the seven sisters and pursued them for a long time. Eventually, Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert region near Aldea in outback South Australia. Orion's described as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire and represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hyades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. And this causes Orion great humiliation, putting out his fire and allowing the 7 sisters to escape. Now, one of the interesting facts about this ancient Dreamtime story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a 400-day period. The Pleiades' 7 sisters story is remarkably similar to legends found in many other cultures around the world, and which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the 7 sisters nickname. But this spectacular open star cluster actually consists of more than 100 stars. Now, if you follow Orion's belt to the east, it brings you to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. To the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motion across the sky. Now, if you look high in the southern sky in February, you'll see the star Canopus, a white supergiant located 313 light-years away, the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Puppis. Also in the southern skies this time of year, you'll see the large and small Magellanic Clouds, which are 2 dwarf galaxies orbiting our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori and served as important navigation markers. They're named in honour of the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself didn't complete the circumnavigation. He was killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead and is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers have classified it as a disrupted barred spiral. It's around 14,000 light-years in diameter and contains about 10 billion times the mass of the Sun. Located slightly lower and to the west, you'll see the Small Magellanic Cloud, which is located around 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it too was once a barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. And now to help us check out the rest of the February night skies on Skywatch, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
So what can we see in February? Well, we've got the Milky Way, which is our galaxy seen from the inside, of course, and it's stretching right across the sky from the south to the north. And the Milky appearance, of course, in the Milky Way just comes from millions and millions of stars that make up the Milky Way, but they're too small and indistinct to be seen individually by us the unaided eye, but they all blend into this one sort of milky thing that stretches across the sky, which you get the best view of if you get away from the city and you get out into the countryside where you don't have any light pollution, of course. That's when you can really see the Milky Way standing out. A lot of people who live in cities just don't even see the Milky Way because there's just too much light pollution around. It's really tragic. Anyway, along the Milky Way, where the bulk of the stars of the galaxy are, this is where all the lovely constellations with their bright stars and also a lot of what astronomers call deep sky objects, such as star clusters and colourful nebulae. So right down in the south, this time of year, we've got the Southern Cross, as usual. Above it, we've got the three constellations that used to be one constellation before it was split. It used to be called Argo Navis, the ship of the Argonauts from mythological fame, but it got divided up into three different constellations to do with the boat, the ship of the Argonauts. You have Vela, which is the sails. You've got Carina, which is the hull and the keel, and Puppis, which is the poop deck. And there's actually a fourth constellation that used to belong to Argo Navis too. A very small constellation, not too prominent. It's called Pyxis, and that means the maritime compass, which makes a lot of sense, of course. Constellations, by the way, are simply sort of join the dots affairs using the brighter stars in that particular pattern in that part of the sky. They don't actually mean anything scientifically. In fact, officially today, constellations aren't even sort of the join the dots shapes that go back many, many years. They're simply boundaries of area within the sky, sort of like state boundaries within a country. They're just a man-made invention that makes it easy to describe where things are in the sky in a sort of general sort of sense.
Beyond Puppis and high overhead in February, you find a constellation called Canis Major, which simply means the large dog. And yes, there's also a Canis Minor to go with it. That's the small dog, and it's a little way away from the large dog. The brightest star in Canis Major is actually the brightest star in the night sky overall. It's called Sirius. Now, when we say it's the brightest star in the night sky, it's the star that appears the brightest to us here on Earth. There are stars here in space that are much brighter than Sirius, but they will be further away and therefore will seem a bit dimmer. So there's sort of ways of measuring brightness of stars. There's how it appears to us from Earth, depending on exactly what kind of star it is and how bright it intrinsically is, plus also whether it's close to us or far away from us. And then there's the other way of measuring, which is a sort of standardized measurement of just how intrinsically bright a star is at a standard distance. And they call that absolute magnitude. So Sirius has a very high apparent magnitude because it's quite close to us and it's a fairly bright star, but its absolute magnitude will be dimmer than other stars out there. So there are plenty of other stars out there in the night sky. If they were closer to us, would far outshine Sirius. So Sirius just happens to be reasonably close, fairly bright star.
Well, Canopus is normally the brightest star in our night sky. It's only during human lifespans that it's been overtaken by Sirius.
That's right. Canopus is the second brightest, as to our eyes right now. It's the second brightest star in the night sky. So Canopus is a star that's in the southern hemisphere, and it's a glorious-looking star. But as you say, see, stars change in brightness, and stars move further away from us and get a bit closer. There are all sorts of reasons. And there's also, we talked about constellations earlier on. You know, they list the stars or the bright stars in constellations according to their level of brightness. So the first star is called Alpha such and such, or the next one is Beta such and such, with the such and such being the constellation. So Alpha Centauri and Beta Centauri and Delta Centauri, Gamma Centauri, going down through the Greek alphabet. But some of those stars, since those designations were made, have changed in their brightness. So some Alpha stars in constellations are now dimmer than the Beta stars. So things aren't quite as unchanging up there in the sky as you might think. So yeah, so brightest star in Canis Major is Sirius, the brightest appearing star in our sky. In Canis Minor, the sort of neighbouring constellation, the small dog, you've got the bright star Procyon, which is the eighth brightest star in the night sky. Anyway, if we keep going along the Milky Way, beyond Canis Major, we eventually get to Orion, the Hunter, which we've spoken about many times. It's surely the most magnificent constellation in the sky because it's super prominent. And beyond that, you get the constellations of Gemini and Taurus, which are sort of through the zodiacal area of the night sky, where the zodiac constellations are. Gemini is quite easy to spot because there's two fairly bright stars near to each other. They're called Castor and Pollux. And because they're basically the same sort of brightness, and they're close together, Gemini, the twins, right? Makes sense. Taurus is pretty easy to spot too because it has a very obvious wedge-shaped grouping of stars that includes a star cluster called the Hyades. Now, you can see many of these stars in this cluster just with your own eyes, but a pair of binoculars, if you've got them, reveals even more. And there's another star cluster nearby. We've spoken about it on the program many times. You can see it with the unaided eye, and it's called the Seven Sisters, or the Pleiades. Most people can see about 6 or 7 of these seven sister stars. That's why it's got its name, of course. just with their own eyes, but a pair of binoculars will show even more. And if you have a telescope or a friend's got a telescope and you aim it at this little cluster, you'll see lots more fainter stars. I think there are about 1,000 stars in that star cluster, but most of them are so faint that you do need a telescope in order to see them. Anyway, on to the planets. As far as the planets go, the ones to look for this month are Venus, Jupiter, and Mars. Venus can be seen low above the western horizon after sunset, and if you keep watching as the weeks go past, you'll notice it getting higher and higher each night. You really can't miss Venus. It's big, bright, and white. It's very easy to spot. Jupiter is in a similar part of the sky, however, and it's also big and bright, so try not to get too confused. So it's above the western horizon after sunset, but as the weeks go by, it will get lower and lower in the sky, and it will eventually disappear from view because it's heading around to the other side of the sun from us at the moment, so it's going to drop out of sight for a while. That's next month. But throughout February, we'll still be able to see it. In fact, if you take a look on the last day of February, or the last night of February, I should say, you'll see both Venus and Jupiter fairly close together, low in the sky above the western horizon after sunset. That should be something pretty nice to see because they are two big, bright planets, and they'll be pretty close together. And as for Mars, well, after sunset, you'll find it about halfway between two of these things we were talking about earlier. It'll be halfway between the Hyades star cluster and those Gemini twin stars, Castor and Pollux, mentioned earlier. Mars isn't as big and bright as prominent as Jupiter and Venus. It just looks like a sort of medium brightness, orangey red star. And at the moment, it's getting further and further away from us as we race along in our orbit, and it's going a bit slower in its orbit. We're opening up the gap between us, so it's actually appearing smaller and smaller, therefore dimmer and dimmer as the months go by. We won't have really good views of Mars again now till towards the end of 2024 is the next time that's going to be good for us. And that, Stuart, is the night sky for February.
And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.